Hey everyone. In today's video, we're going to see about AI roadmap for the year 2025 and 2026. Because if you are someone who's looking for a complete map, a tracker for your AI engineering or any AI jobs or roles that you're seeking for, even if you're a fresher, experienced person, this map will guide you throughout. And end of this session, I'll be sharing the 6 months tracker and the topics that you need to cover, and also some of the sources that you can follow and get your knowledge from, like YouTube videos, link courses. So you can cover everything in this video. So don't skip any part. Let's get started. So, yeah, it requires 18 months, of course. And if you are dedicatedly focusing towards it, like spending 4 hours in a day, 4 hours in the sense, not like distracted 4 hours continuously, dedicated 4 hours. You can take breaks in between, but still, like fully focused 4 hours in a day can make you an AI engineer or any AI preferred job roles. So 18 months is like more for someone who have the basic about machine learning, those things. But if you're like going with something higher level, it requires that much long. So 18 months is your base period, I mean duration, to cover this entire map. I mean, the syllabus. Let's cover like 24 core topics that you should, I mean, must know about. And yes, same thing, 18 months in the sense like you should have at least a spend on this topics or core topics that we going to cover in this video for about 1000 plus hours. I'm saying hours and months is because you need to spend so much of time experimenting things. It is not about taking notes and memorizing stuff. You should have practical knowledge about it. So that is what I'm like talking about, this hours, months, and days and all. So projects, yes, must, should, or have done 6 projects minimum. Six in the sense like minimum I'm talking about. And it will have different variations. I mean, the topics for each projects should be different. So these are like basic fundamentals. And let's just go into each phases that you know, uh, you are into, that you should be into. So foundation one. So complete roadmap I'm giving now, or I'll start with beginner tracker. So basic things that you should know is mathematics and stats. Mathematics is not about you should be expert or you should become someone like Einstein and all. That is not necessary. All you should know is linear algebra and statistics. You should know this permutation, combinations, and probabilities, and some of the distributions you should know, and hypothesis testing you should know. In mathematics, you should cover this discrete mathematics. It's a theory, basically discrete, if you are someone who know what is discrete mathematics, and experiment things with that. Calculus it's a vast, actually. You can't just cover calculus in 18 months or in a year or something. It requires a lot of internal knowledge that you gain using calculus. So don't go mechanical. I mean, don't go into mathematics like numbers immediately. Just have something like real time problem solving, so that it will be easy to remember those things. And if you are studying one topic today, don't immediately move on to next topic tomorrow. Just have this entire flow within you. You study today and revise tomorrow, and after a week just have this thing revised for a week, so that you will have this note maintained, that what are the things that you remember, well, things that you don't remember. So that is how you should be able to remember things, because I was doing that. It will be in your temporary memory, right? You can't just rely on this thing like a system. It's a human brain. We get distracted. We talk to people and we forget things. So good practice. The best practice to have something long term. You should have a proper notes, and not memorizing, recall things that you studied. If you are practically practicing each and every concept with any examples or solving sums or practically experimenting things, you'll remember forever. So that is one thing. Python program basics. Most importantly, instead of like going with this full stack kind of programming, have this basic packages known. Pandas, TensorFlow, PyTorch, Spacey, NumPy is very important to if you are like someone who is good with linear algebra. NumPy is very important for any algorithm that we are going to do, like from linear regression to neural networks. NumPy is important in order to, because it's a matrix multiplication, right, at the end of your topic. After all, it is a matrix. So you need to know NumPy. Just understand what is NumPy and what are the things that you can do in NumPy, like multiplying things and assigning weights to a particular node. So those things just understand. I specified hours here. It's to have minimum. You can practice everything in a day, like whenever you want it, how long you want it. So it is depends on you, because study plan will be different for everybody. But still, I'll give a overall study plan for you so that it will be easy for anybody. You can modify based on that, based on your interest. So core topics, yes. Visualization, data visualization is must concept that you need to know. For that, you can learn this matplot library and cbond. They have this entire packages like for box plots, linear line plots. So they have this entire thing in that, so it will be very easy. And also they have this inbuilt packages, so that visualizing things will make you learn faster compared to the coding. Mm. The next thing is projects. So try to build projects for each and every topic that you do in if you are practicing Python. So I would say take this WhatsApp chat if you are someone who use WhatsApp, or if you are in group, just take out the export the group chat. If it is a non-official group chats, just export it, clean the chart completely, and visualize and see, like analyze the data, text data. Text data is easy to analyze. Also, you can see the words, number of words, and what are the topics that you are discussing with that. So who's actually chatting more, who's available, who sent so much images, who's sending emoji, more emoji. So these things just try to practice. And I uploaded this video, actually WhatsApp analysis that I made like years back. I was a beginner that time, so I wanted to do something like that to. I was learning, so I did that. It was very helpful. So you guys try to do that. Next thing is AI fundamentals. This is now we have this AI thing. So for that, just understand what is AI before going into AI. I would say understand what is machine learning, the types of machine learning, and next move into deep learning. Later come to NLP. NLP, if you are understanding, like NLP is about text. The for numbers we go with regression, right? For classification we can go with anything like numbers, this thing, that thing, everything. But numbers we generally go with regression models. Likewise, for text data, we go with NLP. So NLP is about text. So understand these things and you will easily understand AI. So the AI is like the last thing that you need to focus. Before that, just go through all the curriculum about machine learning. Just understand what it is, and the algorithms. Just practice. Take out some data from Kaggle or any open source machine learning platforms. Just get the data, or you can prepare your own data. Build a model, clean the data, pre-process it, understand the distributions, how it is actually distributed, validate it, and see how much accuracy you're getting in every algorithm that you're using. It varies for supervised, unsupervised, that depends on you. Just take out and practice. So these are the basic thing that you need to do if you are someone who's fresher. And if you are someone who's intermediate, you should know all these before starting into something, advanced, more advanced, like AI concepts, Gen AI, those things. Next, intermediate. Intermediate includes machine learning, the feature engineering concepts here. So, if you go with machine learning, it is more about the linear and non-linear algorithms that you will be more focusing on. So, the basic algorithms like linear, logistic, that is all done, and neural network, basic neural network, that is all done. So you should come up and do some more, which is about non-linear, like polynomial regression. So these things you should know about, and concentrate more on feature engineering, like PCA, how to reduce the dimensions of your data. If you are handling something like 5,000 columns, how you will actually redact it? You can't just go with correlation matrix every time. So you need to do PCA, or if you are like going for any feature engineering stuff, much better models, you can go with that. So it is all depends on you. If you know everything, you will choose algorithm which will be perfect for this data. That knowledge you will get only if you are practicing enough. So you can't just go directly like choosing, oh, okay, I read this algorithm, it is for regression. I can't just go with that. So I'm just going with that. So you will know regression and classification models for which data that you can preferably go for regression and classification. But what algorithm that you should use for regression problems, you should understand, you should realize like how it is giving. So you can't just you can't implement only one algorithm, or you can't go with only one algorithm. That is not data science. You should try everything. For that, you should know about it. So for that, just understand what is feature engineering. It is a major thing in this data science. If you are in this field, you will know what it's about, and how much it is important to. It can change the entire result. It can change the entire belief about a particular research. So feature engineering and data pre-processing is very, very important. Just explore more from it. Many models, approaches, and types you can try with that. Even you can do this normalization techniques for it in feature engineering. That also you can do. So it is all about experience. Okay, you can't just rely on books completely. So explore more. Next, validation. So this is where you actually give the accuracy. I mean, this model is believable. This model gave me this accuracy. We can go with this. So this thing, model evaluation or optimization is the final. I mean, the result, right? That's where you present with your audience, with your team, that I did this, and you just have to make them believable that make them believe that this is done and it is working. So model evaluation and metrics that you can try more than accuracy. Some of the metrics like mean absolute error, R square. So those things all combining all together, recall, precision, F1 score. So those things are there. Hyperparameter tuning, grid search. So everything is there. You need to explore more. I have given some of the things here, and yeah, so good. So Bayesian optimization, ensemble methods. In the science, like you just take one model and compare with the other models and take an average of the accuracy and give it back. So this is like currently for AI they are using this thing, ensemble methods. That is one sample. Next, advanced. So for the advanced, I'll just give the overall roadmap. So we saw all these things, and here we go. Deep learning. Deep learning is about the previous step for your AI. So deep learning is for the large set of data. That is what we had, like more corpus. So that is what that is what we went for deep learning. So deep learning is completely on any kind of data that we can go with deep learning models. You can train text data in CNN or numerical data using CNN. CNN, we thought it will be for the image, right? But it is not. So deep learning is for everything. Recurrent neural network for the sequence models. Like if I'm talking, I need to predict what will be I'm using the next word of mine. So I can use recurrent neural networks for that. Like sequence modeling, I can use LSTM, I can use GRU. So these things are from deep learning, and it is pure mathematics. All you need to know is the steps. And this gradient descent is the key for your deep learning or any model that you do. The back propagating, what it makes to back propagating things, what is learning, what is epochs, how many learning rate, how much, I mean, the value that you need to give for learning rate, 0.01y, and number of epochs, how many iteration that you can do. So these are things that will comes with an experience. It is not in one go, right? Fine. So neural network fundamentals, anything you take, don't go by books. It's not going to help you in any way, because if you are someone who's in school, maybe to get good marks, yes, but you have to do it practically, and your projects will be used by people. So if you are someone who's like taking notes, memorizing, and just by harding things and just saying it to your interviewer, it is not going to help you. So you need to experiment things and do it by yourself, because nobody is there to help you, and everybody is new here in AI era. Everybody's learning, so it is a competition. You need to expose yourself with so much knowledge that you are gaining with. So have research skills. Computer vision is another thing that it is for any of your image processing data, handling image processing, images basically. So it will have this video, images, and continuous monitoring of faces for security breaches, if anything suspicious activity in the image. So you need to do a lot of research on that, like identifying knives through image. This YOLO projects that have you heard of? So it is about computer vision, right? So if you are going with that direction, this is a major breakthrough. It will be a major breakthrough in your career. So it is completely unique, and it is good also. In demand profession, computer vision projects, just have like n number of projects, understand what you're doing. Just don't go with pre-trained models and all. We build from scratch, from data, collect data and do it. So as I told, natural language processing, it is about data. Later it comes with your reinforcement learning. Reinforce in the sense, like you have the semi-supervised learning, you have partially labeled data, and you will have the unlabeled data. So you need to train a model to label those unlabeled. So that learning will happen. It is like feeding your dog. Like if you're behaving well, I'll give you treats. If not, same thing, like feedbacks, reinforcement. Later we have this Gen AI. So Gen AI and stuff, this AI ethics, responsible AI, MLOps, model deployment, AI architecture, capstone projects. Capstone project is about your RAG and all it will have. So end-to-end pipeline, the entire model. So I'll just give this overview. LM, it is a package, right? Not a package, it is a model that is offered from any like Google, OpenAI, those things. Gen AI for your text data. Whatever text that you feed, it will understand. That is your Gen AI. Writing prompts and talking with your AI through text is your Gen AI. From there, we are building models. You can make a system understand without writing a code. You can just give a prompt like, do this for me, do that for me. So that is your Gen AI will do. Next step is you're building AI agents with that, like instructing your AI agents to behave the way you want it. That is next step, and building applications with that. So simply, they just simplified everything. All you need to do is just practice enough to get and understand, build ideas. idea actually very important, so that you can have a brilliant product and publish towards audience or customers. You can just have a startup with your like basic idea. Comet Perplexity is one of that, and they just had this vision, and with the AI agents they just built this entire browser. Simple. So it has everything. All you need to do is just type everything, and with that you can just build models using that. You can just instruct your AI to do things. You don't have to write code separately. You can just instruct. You can ask it how to build something, and it will do for you. And you can instruct how to behave in certain cases. You can build applications through it. So that is what this Gen AI, and your the next step is building models using Gen AI. That is next thing. So understanding that takes a lot, and later how to deploy everything as a product. That is ML ops comes in. That's where. So model deployment is very important after this AI evolution, because back then we have this pickle file. We can just store the model, train the model. It won't exceed like more than GB. But now it is not like that. We are handling billions of parameters. So you should know about fine tuning the pre trained LLMs. You can use the existing base model and you can fine tune it. So understand what is that, and how you can just save the model in buckets, in cloud, like how you actually going to do that, how you can deliver your product. So Vertex AI came, and we are using those models from Google. How we are using that? So how you actually publish your your trained model towards audience. So you should understand all those things, and it requires like months for this. Dedicatedly just have access for any cloud platform and understand Kubernetes, which is important, and just know how this ML flow works. Later go with ML ops and those stuff. So AI architecture is one thing, one more thing, and it is off about all your AI things that you do. From data pre-processing. Data pre-processing, some cases not required if you are using LLMs, because it can understand. If you are not allowed to use LLMs, you need to do data pre-processing and understand what can an AI can do, because AI is like huge data, right? You can't just go with simple and delicate models for it, vulnerable models for it. Like you can just go with your machine learning, deep learning models instead of going for AI. But for AI, you need like certain range of parameters. And what all you can do with that? You can build the entire flow with it. So building architecture for handling AI is completely a different thing than your deep learning and traditional machine learning models. So understand that Apache Kafka is for the streaming data, Apache Spark for big data, NVIDIA Tensor RT for optimization, Kubernetes orchestration. So just understand what it is. You don't have to know like everything. Just understand. Have experimented one thing at least, like very strong, like one reliable thing. Have that, and you're good to go. If you are dedicatedly spending your 18 months on these things, knowing everything, and experimented, have like 6 to 7 projects in hand, experiment all these topics, enough. You are done with that. You can blindly apply for any jobs, like any fang mang, whatever it may be. Just you can just apply. So I'll share this 6 months tracker. Okay, so this 6 months tracker with you people, so that you can just have this course planning to complete for every week, and the resources links I have given, so you can just go through this thing, and you can change accordingly, like the way you want it. That is also there, and I'll also share this git link for you guys, so that you can refer tons of models, courses, YouTube links, and a lot of steps that you can follow for your AI journey. And I'll share the syllabus also, so that you will know like what all the topics that you can cover. So yeah, that's all for this session. I know it will be boring, but if you are passionate about earning money, get it done. Okay, see you next video. Bye.